So here in the Java API, I have the object class pulled up. So in Java, there exists a class, and it starts with public class object. Within that class, you can see that there's a constructor and several different methods. You can see the different methods' names, return types, and descriptions of how they work here. The most important thing to know about the object class is that every class in Java extends the object class. So here I am in Eclipse looking at the bank account class that I've created. So we've created this file or a similar file in previous videos. And you can see over here the file system or the project folder that bankaccount.java is in. Notice that there's nothing in here called object, so I do not have to define the object class. It already exists for me behind the scenes. Now the important thing to note is that this class, just like every class that I've ever created, does in fact extend the object class. Now even though I don't see the keywords extends object here, you can imagine that it's there because literally every class we've ever created, albeit this tester file over here, the bank class, book.java, dog, any class that we can create, naturally extends the object class in Java. So going back to my example here, I could actually take these keywords and plug them in here. Note that if I save this, there is no error here. So even though object is not defined in this scope, it knows the object class and has access to it. Also note that just because I put these words in here does not change the nature of this file. Everything here highlighted in blue is already there behind the scenes. We just don't physically see those words typed out. So what that means, I'm going to leave this here just as a comment so we can imagine that we have the words typed out. What that means is that just like we saw with our savings account class in another video extending bank account extends object. So everything that is in the object class, all of these methods are here for the bank account class to use. That means that there's a method called equals, there's a method called toString, and there's all kinds of methods here that we can use. However, it's not common for programmers to call many of these methods. So let's look at where this might be important to us, that bank account, or again, any other class that I create, extends the object class. Here I am in a tester file, and I would like to create an array list that holds all kinds of objects. Now, within these two carets, we typically put whatever type it is that we want to store in the array list. So for example, I could store an array list of type bank account by putting the word bank account in here. I can also store an array list of strings like this, or I can have an array list of integer if I put the wrapper class integer in both of these. But if I wanted to store an array list that held multiple types, let's say I wanted to store both strings and bank accounts together for some reason, then I could put an array list of object. Again, note I haven't had to import anything besides just the array list class. Java knows what the object class is, and you can see it pointing to it if I hover over it. And what this is it's an array list that can hold anything of type object. Well, the key to this is that everything we've created is type object. So a string inherits from the object class, and the bank account class inherits from the object class. So what I can do is, because of the idea of polymorphism, let me type this out here. What polymorphism tells us is that if we have a class like savings account, and savings account has extended bank account, so it is a bank account, then we can fit a savings account into spaces designed for bank account objects. So on this similar vein, bank account is a object because we saw that it extended object, and then string is an object, dog is an object, and every other reference type that we've ever made is a object or inherits from object, right? So I can put anything that inherits from the object class into this array list. First I'm going to create a string. I'll call it name, and I'll put Dr. Agar. Again, because the string class extends the object class, a string is a object, so I can put a string in a space that's dedicated for an object. So what I'm going to do now is I'm going to add it to the list. I'm going to say some things, which is just the name of my array list, dot add name. And now to build onto this example, I'm going to create a bank account. I'm in the same file here. You can see my tester file is in the same file as my bank account class. So I'm going to create a bank account. I'll call it my account equals new bank account. Just call that default constructor here. And then I want to add my account, which is type bank account, to this array list. So I'm going to say some things dot add my account. Again, because a bank account is a object, I can fit a bank account in this space where an object is expected. There's really no limit to that. We can do this with anything that is a reference type. So just as another quick example, I can create an integer. This is just something of the wrapper class, x equals 5. Also note, I could have done this the long way by saying integer x equals new integer and passed in 5. Both totally fine. This is okay because of auto boxing. I'm automatically boxing up this int into the integer wrapper class type. And then because I have integer, and integer is a class in Java, we know now that it extends the object class. I can then add it to the SomeThings array list the exact same way we did above, SomeThings.add x. Now what I'm going to do is I'm going to loop through this array list. I could do either the normal for loop here or the enhanced for loop. With the normal for loop, I can use indices, create an int I equals 0, go through, but not including SomeThings.size, and increment it each time, get each object out. I'm going to create the enhanced for loop just because that's a little bit different. I feel like that's what more people would struggle with. So I'm going to pull out each object, and I'll call it O, from the SomeThings array list. It looks a little weird because we're not used to using the word object, but note that we're following the pattern that we always have. We're putting the name of our list on the right. On the left, we just put the name of each type in the list, and each type is a object. They're subclasses, but we saw that bank account is a object, integer is an object, string is a object, right? So we're going to pull out each object, and then I'm just going to print the object, system.out.println O. Now before I run this, I want to think this through. We know that array lists do store order, so the very first thing that prints out here should be the very first thing that was stored. That was this string name Dr. Agar. So when I print out O, I would expect to print out Dr. Agar, just like we normally would, right? The next time, I'm going to grab the bank account. What happens if we typically print bank accounts or other reference types? It should print out a memory address. So we're going to print out the memory address next. And then last but not least, this is an integer, which we know can auto unbox to just print 5, just like an int would. So we would expect Dr. Agar an address for the bank account and then 5 to print from looping through. I'm going to save and run this. And you can see that it works as expected. Now let's explore some common mistakes and solutions. I could not have changed the type right here that I'm pulling out to be something like string because not everything in this list is a string. When I pull out the first object, right, it happens to be a string. But when I pull out the next one, a bank account, and then the next one, an integer, they're not going to fit in this type string. So we do have to leave this as an object. With that being said, I want to talk about casting. Remember, we talked about typecasting or casting back when we talked about mathematical types. We could use the parentheses and put something like double or int to typecast these mathematical types back and forth. Just as a real quick example to refresh your memory before we do this, I can say something like int x equals cast to an int some double value, right? So in this example, it's going to take the double, it's going to cast it to an int so that it can fit in the space for an int. So this was an example of casting. And that exact same concept can be used to cast things from the object class to their subclasses. So for example, I'm going to just leave this here as an idea, but let's say that instead of printing the memory address, when we printed the bank account, I wanted to call the bank account's print method. Now I am going to inspect my bank account and make sure it does have a method named print. Typically, to call the print method, I would need to call it with a bank account object. It's not a static method, so we need an object of type bank account to call it. However, when I come back to my tester class, I can't say o.print for several reasons. First of all, when I come through this for loop the first time, O is not type bank account at all. It's an object, but it also, at its subclass roots, is a string. So the string class does not have a print method to call, so this is going to be an error for the first iteration, right? In the second iteration, though, it is a bank account. So the first thing I want to do is I want to detect if that object is a bank account before I try to call bank account methods with it, right? So again, what I would like to do is if O in that iteration is an instance of the bank account class, then I want to use it to call the bank account's print method. So instead of using the word is a here, I'm going to substitute that with instance of. And so let's just read this through again. If the object O is an instance of type bank account, then I want to use the bank account's print methods. So the way that I've written this out here, instance of, is an actual keyword in Java, and it's going to allow us to do just that. I'm going to say if O instance of bank account, and you can see here that instance of turned purple. That indicates, just like the words if, for, static, public, all of these other words we're used to turning purple, it is a keyword in Java, and it's going to have some kind of special functionality just like the other keywords that we're used to. So it's going to check whether or not O is an object or an instance of the class that we put here. As long as the class is in the same context that we can see that it's visible, then this is going to be a valid piece of code, and it's going to return a Boolean, true or false, here to answer our question. So basically what we would like to do is if O is an instance of bank account, then we want to use the print method. So I'm going to move this over and put it inside this if statement. However, I'm left with one more problem, which is that the object class, which O is type object, does not have a method named print. I can even flip back to my API, and there's no method in here named print. So I cannot use a print method with something of type object. What I can do, though, is use this idea of casting to take the bank account object out of the object class and cast it to something of type bank account. So what I'm going to do above here is I'm going to say I would like to create enough space for a bank account, even though this is not going to go get new memory. It's just a placeholder or a variable name indicating that that variable is going to be type bank account. And I can call it whatever I want to call it. I'm going to call it B. And I would like to extract from this object the bank account. I'd like to downgrade it. Now, if I think about this, comparing this to what we did up here with the types, without typecasting, I'm going to remove this typecasting statement up here, we can view this as trying to downgrade a double to an int. But we know that even though I can do that, I should be able to extract a whole number value out of this double. It's not going to do it automatically. We have to tell Java, hey, I'm trying to typecast this or downgrade it to this smaller type, right? So what I'm going to do here is I'm going to downgrade to a bank account. Now, as long as these types match up and B is actually type bank account, then this is going to work. And then the only thing I need to change is, again, I'm not trying to call the print method with O. O is still type object, but I am casting it to something of type bank account named B, and I can use B to call the print method. However, the print method is void, so I don't need to put it in a print line statement, right? That does double work there, and it's not going to work because I can't print out void, but I can just use B to call the make account print method, and that will make all of these print line statements run. So now I'd like to think about what this looks like. actually, if we were to run this right now, it's only going to print something for a bank account. I've, in fact, gotten rid of the line of code that would print for any other type. So I'm going to put my statement back in here. I'm going to say else. If it's not a bank account, then I'm going to just say system.out.println O, which is the line that we had before. So if it's a bank account, then don't print O, because we don't want the ugly memory address to print. Cast it from the object to the bank account so that we can use bank account methods like the print method here. Otherwise, if it's anything other than a bank account, in our example, this was a string, this was an integer, then we're just going to print out the values. Now, I could have made this a multi-branch if-else statement to check for instances of any type. Maybe if it was an instance of string, I wanted to print something else fancy using the string class. I can certainly do that, but I'm going to leave this example at that. I'm going to save and run it just to make sure the output is as expected. And you can see here that the first iteration, O, was not an instance of bank account because it was an instance of string, right? So it skips this and prints out O, printing out Dr. Agar. The next time this became true because O was an instance of the bank account class. Again, it's a really neat tool that's not covered in your textbook that discusses how to do this. We cast it to a bank account object, call the print method. Very cool here. And then the last time, this integer is not an instance of the object class, so it's going to skip this if statement and print out the value of 5. I hope that's helped clear up some things about the object class. The last thing to talk about is practicality. I often get excellent questions about when should I use this? Is it good practice to store things of all different types under one list or one collection? So it really depends. If you just want to store bank accounts, then create an array list of bank accounts, right? That would be the simplest thing to do. The same thing if you just wanted to store strings. So it is not always best practice to just throw something in a collection of objects. However, this allows us to have some flexibility in our design. If we have no idea what is coming in, a lot of times this works in like websites, we don't exactly know what's going to be passed into us, then we can create these placeholders of type object and then work with whatever gets handed to us. So it does give us a lot of flexibility when we're designing bigger programs. All right, I hope this has helped. Until next time.